we have a discussion on low power design and where we add. To start the discussion, before the discussion, I would like quickly want to introduce our panelist, Vanja, the founder of CEO of Qoitech, Xavier Dupont, leading business development of SG Wireless, and Ancient Giaimo, the head of LP WAN product marketing of STMicroelectronics. I'm going to quickly open to the panelists so they can introduce themselves. Vanja.
Thank you. So I'm Vanja Samuelsson. I'm the founder CEO of Qoitech. We are a Swedish company. Actually, we are a spin-out of Sony Mobile Communications. Our background is very much into the low-power design of cellular and non-cellular technologies. What we are doing is development tools for energy optimization of IoT embedded devices and helping developers find the perfect match between their application and the battery for the longest battery life.
Hi everyone, I'm Xavier Dupont. So I've been in this IoT space for 20 years. Started in 2003 over cellular, then we moved to Zigbee and lots of different low power technology. Before we used to talk about LP1. In my career I deployed around 3 million devices. In some application the low power was always a big challenge, metering. When we were talking about water meter and battery powered solution, and transport, where we were talking about telematics and tracking device. So as a users of this technology, we always had to find a trick and the most optimized way to use different technology bricks in order to achieve the power which the use case and the application needs.
Okay, hello everyone. So my name is Anicet Giaimo. I am product marketing manager in STMicroelectronics, and I'm responsible for our system on chip. So our system on chip that are integrating the microcontroller, the low-power microcontroller, and the radio into a single device. So where the low power is really critical, so we are using our low power platform on the MCU, and we are optimizing the radio as well into an integrated product.
Great. Just to start with the conversation, just to forget, I introduced myself. My name is Satyajit. Sinha. You can call me Satya. I'm principal analyst in IoT analytics. We are market research provider. We provide market intelligence to chip-to-cloud ecosystem. And the topic is very interesting. Like low power designs, and it is very important for the IoT perspective. Start with all the panelists. One key question: how critical is low power designing and then deploying? And what are the key trends you are seeing in the market specifically for low power design based devices?
I'm starting here. Yeah. Yes. So, I mean, critical, I don't think we need to really dig deep there to find out how critical that is. What we are seeing now is that there are a lot of deployments out there, and now we're actually seeing a little bit of a backlash on the low power because there have been a lot of over-promising in that sense. So I see specifically two things happening. One is a lot of deployments coming up, maybe promising 5 years of battery life and now delivering only on two years of battery life, or software updates, for example, that are not being really checked for power, meaning draining battery for new releases. So there are a lot of these things happening now that are showcasing that we have been maybe a little bit over-optimistic in when designing for the low power. So this is the negative trend that I'm seeing. The positive trend is, of course, that people are now looking at this a little bit more from holistic perspective and not just, oh, the hardware needs to be low power, but more of the things need to be low power. It's a full stack.
Very interesting. Xavier?
So yeah, how critical? I believe it's always, of course, related to application. So in an LP1 exhibition, we'll be talking about the low power. But I also have a big part of my business, which is over cellular, even 5G application or Wi-Fi. Let's remember that it's still a big part of the deployment today. The concern is less, even though, interestingly, there was this exhibition in Lyon called the CIDO. And for the first time, how French people love to do protests. And there was activists which were there to talk about how techno-solutionism is not the solution, and how trying to put all these sensors everywhere will just damage the planet. So clearly, application-wise, depending on how you make money out of the data you collect, is important, but also environment. There will be more and more concern in the IoT space that what we do is polluting by putting battery everywhere. So pretty much critical. And some of the trend I think I see, the one I like, and I think it's getting mature kind of year zero to me, it's energy harvesting.
Sure.
We are definitely exploring what we can do there. The work which is done on batteries also is definitely, we are talking lots of things still happening in the lab, not fully ready for the market, but I believe that some good stuff are preparing.
Great. Inshin?
Well, yes, so as we said, low power is really critical in a way that it's a way to reduce the maintenance cost, because you do not want to replace your battery quite often, and especially in some use case where you have a device that is remotely located, difficult to access, so you do not want to have a technician or an operator to go on the field and replace the battery. And also the battery itself is all cost, so if you can reduce its cost, it's a way to reduce the overall cost, and also reducing its size, the size of the battery. We are talking about IoT sensors that could be with really small form factor. So size is quite important. And then it's also a challenge on the other side to optimize it. It's a challenge, I would say, on two aspects. The first one is on the chipset, because you need to optimize the chipset both on the dynamic power consumption, so both on the computing efficiency, and as well as the static power consumption, so the leakage of the product has to be as small. So it's really a trade-off to find, and also to create enough mechanism for the user, the end user, to optimize it. Because it's, for the end user, is a challenge as well, because he needs to find, depending on this application, he needs to optimize and to find a way to make it efficient enough. I like to take the analogy of a car. It's not because you have the most efficient car that you are able to save your fuel, you know. It depends the way you drive it. So this is where the challenge is. You provide a lot of mechanism to reduce the power, but then the end user has to find a way to use it correctly.
Interesting. Vanja, I'm coming back to you. I want to understand, I know Qoitech focus on helping developers to optimize the battery life. But I want to understand from you how much in low power devices the battery life impacts the functionality, and where is give and take. What are the strategies that you want to recommend to developers, to optimize the energy consumptions, but also make sure that doesn't compromise the functionality?
Development, because the low power aspect creates a lot of firefighting during the product development, for sure. But it also goes into the maintenance that you were mentioning. There is a lot of communication that you have to do with your customer for them to understand that the total cost of ownership for the IoT might actually be really huge. Because of a simple thing as a battery life. So this is one of those things that the engineers need to understand, and the product owners need to understand and start implementing. So I would say what we do recommend and what we work with our customers, again, to do this more of a holistic approach, saying, yes, it's really great that you pick a really efficient hardware, efficient chipset. This is your foundation. But what you're putting on top of that is almost most crucial, because the firmware, the software that you're putting on top of it, will mess it up if you don't do it properly. And how do you do it properly? Then you go back to the user cases. What is the application? What are you using it for? Is it going to be mobile? Does it need this connectivity? Is it going to be in these low temperatures? There are so many variables which I understand are just talking about them, it gets overwhelming. And then to test for all of these things, it gets even more overwhelming. So what we want to move people is to actually start testing this and not go into this mode of, okay, I'm just going to add a bigger battery and hope that this kind of sorts itself out. So I think holistic approach to say, okay, this needs to be measured and tested throughout the stack. Everybody needs to take the responsibility, and it needs to be communicated to the customer that what impact that could mean on their maintenance later on.
Interesting. Xavier, multi-radio modules is now getting traction, right?
Yeah.
And doing low power with multi-radio module is one of the key challenges. How you are addressing that challenge?
Yes, no, that's true, and it's always going back to the use case.
Yeah.
I would say just a friend just reminded me that an AI chip consumes more or less 500 watts. right? PC chip is 50 watts, and we are 15 milliwatts. So when we are talking about sensor, the application is pretty straightforward. Okay, you know you want to keep it very long time on the field, 5, 10 years. You never want to touch it. You don't want necessarily to have to throw it away because it pollutes. But what about the other application where you need to use multiple type of technology? We had a case where we had to build a router which was having 5G capabilities, plus it had to go with an STM32 on super low power mode when it was just using iOS. So we had in here to make two boards. We had two CPU on the product. It was this multi-purpose kind of gateway. We had our software algorithm, which would be based on the data usage shifting from one to another. It was a pretty lengthy and complex product, I would say. And each time we had to go back, okay, trying to build the scenario 1, 2, 3, 4, 5 on where it will be used. And most of the time, because our customers are very creative to find new ways that we haven't thought about, we kind of miss it. And we have
cases.
to, for the cases, and we have to go back actually and fine tune. So our answer to that was to use a Linux platform and to use very standard and open technology, which would allow to tune and remotely update the firmware either on the Linux CPU or on the RTOS CPU.
Okay.
So, but each time it's a bit specific, I would say.
Yeah.
Having the flexibility on the hardware without over engineering it, it's a very challenging balance.
Yeah, makes sense. Makes sense. Coming to you, Ancient, I want to understand what are the key technological advances we have seen in past few years or so, like to enhance the low power devices to reach its optimum level, to make it much more practical and usable for a longer period of time.
Yeah, so for that, we talk about use case, so I like to take a use
the
case here. And taking metering, for example.
Yeah.
A meter has to stay in low power state for maybe 10 years on the same battery, non-rechargeable battery. So if we take this use case, what happens, actually what the meter is doing most of the time, he's waiting for his next transmission slot. And he's doing that for maybe 99.9% of the time. So it's important to have a low power mode that consumes less as possible, less power consumption as possible, that is able to store the application context. So by keeping retention, RAM retention, for instance, and having an RTC clock with a low power consumption to wake up at the right time. And this is exactly what we try to provide to our developers by having some low power mode, like we say it's a standby mode, and that consumes just down to 360 nanoamp. We are talking about nanoamp here, so it's really, really low power consumption, and that can wake up in a really fast way by resuming the application where it was at the beginning by using this RAM retention, and in this way to really be efficient in the way that it optimizes the power consumption.
Interesting. Coming back to you, Vanja, I think you are working closely with the developer side of it. So what are the key basic, repeatable misconceptions or mistakes, or you can also say, call it a challenges that you have seen that they are doing specifically for low power devices, and how you guys are addressing those challenges?
Surprisingly, it's actually lack of insight.
Okay.
So a lot of developers are provided with a lot of different tools. I mean, you were mentioning you're providing these low power modes, and in the cellular aspect, there is so many things you can kind of go to, and then. But if you don't know what your device is doing, it doesn't really matter. And I'm taking this as one example. We have, every time we come to the Things conference, we have at least 1 or 2 developers coming to measure at our booth. And we will usually joke about it, like, okay, let's see how low power you are, what is your estimated battery life, and always ends up them saying, oh shit, what's that? Oh, no, it's not supposed to do that. Why is it doing that, right? And it's like, okay, let's go back to the hotel room. They do that and come back the day after and like, oh, they fixed something in the firmware. So it seems like that there is this. Sometimes I wonder, like, how can they have a conversation with these guys or with the battery manufacturers if they don't even understand how their real-time power profile looks like for different firmwares, for different applications, for different setups, for even different temperatures for that matter, right? So I think, and that has become our kind of goal here in life at Qoitech, to really promote that and give them those insights and say, okay, now you have a good stepping stone to have these discussions, then to pick the right chipset, to pick the right, to play with firmware, to do regression testing, to see what is really working or not, to automate the thing, to pick the right battery, to have the battery manufacturer look at this and say, okay, now I know what you mean. No, you can't have this battery because you have too high peaks, or no, you can't, this is not going to be long enough for you if you have to cover these 10 different user cases, and the temperature is going to go, it's going to be really hot in Barcelona for your asset tracker, but it's going to be really cold up in north of Sweden. So this is the part where we also feel that that's where we have found our purpose. It's giving that insight, and surprisingly, it's still there. Like, wow, what is it doing? What is it doing?
Makes sense. Yeah. Talking about low power devices, one of the key things that come to my mind is the security. Because security has always been a key aspect of IoT, and what I understand, like, it has been a challenge for every other IoT devices. How I'm going to use Xavier now and to come to you as well. How you are addressing this issue, specifically implementing security in the low power devices where power already a lot of constraint. So.
Yeah, no, that's a good question, because as soon as you look at adding security, you're adding overhead, and with overhead, more data transfer means more power consumption. I believe overall that the protocols we are dealing with are fairly secure. Hopefully, they've been quite designed with the thought of security. Not necessarily in the first version of the protocol, but now they are getting more and more mature, and it's kind of being taken care. We rarely added our own security layers on a low power device when we did that, because it was just killing the use case. And we felt, even if there is, in the way the technology is being done, if it's sending data on one way only, first, you cannot really be hacked, so no problem. If it's two ways, somebody which will manage to hack millions of sensors, good luck to him on a LoRaWAN network. So I think on LoRaWAN and maybe even Sigfox, we are quite okay. And the one actually, when ZigBee, if I remember, 2009, were trying to implement security layers, etc., that was the end of the story, because they started to add profile. At the beginning, the technology was working quite okay. Then they added profile, and which means everybody in a specific use case had to use a specific profile. And they ended up fine-tuning the protocol, and then it was more and not anymore standard. So yeah, that's my short answer.
On top of that, I want to talk about STMicro. STMicro, I know that a long player of secure elements, secure MCUs, always been there, right? For you guys, it's like much closer topic. Like, how do you address it?
Yeah, what I wanted to say is that on security, there is no compromise to be done, because we are really talking about data privacy. We are talking about connected devices that are on the field. So we do not want to compromise security because of the low power. But now, how can we optimize it? How can we make it low power? And this is where come the silicons with hardware encryption, in a way to make it much more efficient. Instead of using the CPU to compute encryption process, to compute hash, for example, what we are proposing here is to use hardware acceleration to make it much more efficient. So that's basically what we are proposing in ST.
Interesting. Yeah, I agree. Like, I think ARM trust zones are one of the key things that I think, that has been implemented in MCUs. Like, it gives you a base, and then on top of that, I guess you are doing secure element. I think you guys have doing in cellular market from a long time. It completely makes sense. Talking about one of the key element also is called, right now everyone talks about AI, and everybody's AI, but now I think for IoT perspective, low power perspective, TinyML make a lot of sense. And in past embedded world, we see a lot of solution. I want to understand from all of you guys, what's your perspective on TinyML implementation of low power LoRaWAN devices, and what are the challenges that you face and how to overcome on these challenges?
I mean, obviously, there's huge usage to TinyML. I mean, I personally believe a lot about the privacy aspects. I mean, that there is a great point of doing that. Nevertheless, that means that the power will be affected. It's the inference models are usually the one that kind of to blame. So I would say you need to really find the right ones. Like how are you optimizing those to not find a nice compromise between your user case and the low power. So it's going to be a compromise, but I think that compromise can be made. I know Agile Impulse used our tools to actually do some testing, and I think they published that as well about how these models influence. And again, the whole point of that was you need to optimize, and I think that's kind of the whole point with the low power today. We need to make compromises, and optimization is the key.
Xavier?
So yeah, tiny ML definitely something we haven't implemented yet, but we had another initiative with an academic in UK which were using our PyCom, former PyCom SV modules. What they managed to do with AI was to do some kind of digital twin of a sensors. So which means on a particular application, they would put some live sensors for some time, they would build a model, and then they would not need to have physical sensors anymore. So they could predict actually the actual, whether it's temperature and humidity. We did it over 2 types of readings. So maybe that's one of the way, which maybe is not good for you because you don't need chip anymore. But on one side is to see how we can use AI to even remove the hardware to some extent.
Good.
And
Yeah.
I think we still need some hardware somewhere.
the gateway.
Don't touch the hardware.
So yeah. But exactly, I think there are plenty of use cases that will benefit from AI, from TinyML. For instance, we can see in the field of sensors. So sensors to optimize the detection, to make it more efficient in detecting presence detection, or to have a more accurate smoke detector, fire detection. So really in a way to make it more efficient, and maybe to have also new use case that we even don't imagine now. So could be for predictive maintenance as well in the industrial field. But then comes the complexity of how do we mix it with low power. So because you need to compute, you need to computation power. So you need a CPU. You need to come with a maybe small process node in a way to make better dynamic efficiency on the CPU side. And again, I will come back to the hardware acceleration again, because then what you could do also is to avoid to use the CPU for that and to use hardware acceleration. This is, for example, something that we are working on in ST with our STM32N6 product to have an internal acceleration inside and to enable such kind of a tiny ML use case, combining with low power as well.
Interesting. Just from a forward-looking perspective, what are the key technology advancements that you see in low power based design specifically, not only devices, but designing on it, and how is it going to influence the upcoming deployments of low power devices? Any thoughts on that?
Yeah, I mean, what I'm curious about, but I will leave it to the experts on the hardware to talk more about it. It's the kind of multi-core processing, the kind of smart wake-up radios, things like what can we do to get that, like go into really deep sleep and really not ruin it by having to wake up for a very long time or something, draw a lot of current there. So there's those aspects that I find really interesting, so I'm curious to hear from you as well. But otherwise, I'm back at the what I find most meaningful is that overall holistic approach. Okay, how it doesn't matter what we implement there if we ruin it along the way. So I want to see really the progress on like this more multidisciplinar and throughout the stack thinking about the power and owning it, picking the right protocols, picking the right connectivity, picking the right battery and the hardware then to fit for the user case. So that's where I stand.
Xavier?
So yeah, to me, I mean, I think there is 2 variables here. When we talk about low power, why do we need low power or low data transmission? Is because the weak point is still the battery to some extent. So of course we have LPM IC. There is a lot of improvement which is being done. Algorithm, whatever we can do to optimize, stop using maybe CPU and using the RF, as you say, to put some security and data is definitely nice. But then it's a battery. There were battery or no battery, like the energy harvesting solution, this which we were mentioning earlier. I think it's definitely a very exciting area, because if it works and you have a very tiny photovoltaic panel this size, which can remove your battery or make your battery almost useless, not useful, then you don't have maybe to optimize so much on the CPU side.
Yeah.
So that's, yeah.
Yeah, right. Yeah, energy harvesting is a good point, yes. What I would like to say is that in terms of advancement and future advancement, we are also working on using new process node, smaller process node, like going to the 18 nanometer FDSOI process on our MCU. And that's a way also to combine the computation power that is required to enable new use case in the future, while still having energy efficiency. Then I was mentioning about the hardware acceleration. And the last point is really about what can it be enabled then in the future, which kind of use case. And here, this is where energy harvesting, which power source we can use. Could be solar, could be haptic forced, could be many things that could benefit from the advancement in terms of low power for energy harvesting.
Great. Just to conclude the session, as an industry analyst, I can quickly say that low power devices bring the volume. Currently, it's 8% of this all over cellular IoT all global IoT connectivity, and we expect it's going to be 12%. So penetration is going to increase. It's much faster growing market. It's bringing volumes. We just discussed security is a key aspect. We discussed tiny ML coming into the picture, sleep mode, other different technology advances going to bring it. The developers with the battery optimization going to bring this technology much farther where we are right now. Thank you, everyone, for this interesting discussion.
Thank you.
And feel free to reach out to us, continue the conversation. Let's collaborate and solve the IoT problems. Thank you.
Thank you.